In this lesson, you will study the most common data structures, that is arrays and dictionaries. In the same context, you will also learn strings in Swift. Arrays and dictionaries in Swift are type-safe. When you declare and assign it to a variable type, it becomes mutable, and when you assign your declaration to a constant, it becomes immutable. Objective-C defines NSArray and NSMutable array classes to differentiate between mutable and non-mutable arrays. Here we declare an array called months. The array consists of 12 elements, each of type string. The values of elements are initialized to 12-month names at the corresponding month index in the array. Note the use of half-closed range operator in the loop construct. The months.count returns 12. The loop continues until index value becomes 11 inclusive. We access the elements of the array by using the typical subscript notation. In this example, the numbers array is mutable as the assignment is made to a variable type. The elements of the array are inferred to be of type integer. The for loop computes the sum of all elements of the array. The last statement computes and prints the average. To modify the array, use any of the familiar syntax. This statement modifies the contents of element 0 of the array. This statement adds a new element with value 78 to the end of numbers array. This statement too adds a new element to the end of array. This statement adds 3 new elements to the end of array. There is an interesting case here. You can replace a part of the array using the range operator. This statement will replace 4 elements with indices from 2 to 5 inclusive of both with the new elements 23 and 32. The array size is automatically adjusted for the two removed elements. You can now print the array for validating above statements. Here is another interesting way of iterating over all elements of the array. We decompose the array into tuples and then print the elements of the tuple. You will learn enumerations later in the course. To insert or remove elements in the middle of the array, use the methods defined in array class. The methods used in this slide are self-explanatory and I will not describe them further. In all our previous examples, we initialized the array at the time of its declaration. You may create an empty array as shown here. Each element of the array will be of type float. The array now contains one element. This statement makes the array empty. You may declare the size of array and initialize all its elements to a desired value using this syntax. Here, integer array will be of size 5 with each element initialized to 0. I will now describe the dictionary class in Swift. As I said earlier, dictionary is an unordered collection of multiple values of the same type. In this example, we declare a dictionary variable called English to French. This is initialized to 6 items. Each item consists of a key-value pair. Both key and value are of string type. For iterating over the elements of dictionary, you may create a temporary tuple. In this case, we create a tuple with 2 values. Both are inferred to be of type string. Why? Because both elements of English to French type are of type string. After printing the dictionary, say you realize that the value for man key is spelled wrong. You correct this by calling updateValue method. You may use the subscript syntax to modify the value of a desired key as shown here. To remove a key from dictionary, either call the removeValueForKey method or use subscript notation to set its value to nil. Here are a few advanced points. If you know Objective-C, you would understand these points quickly. The string, int, double, and bool are hashable types and they can be used as keys. You may also use custom types as keys. However, they must conform to the hashable protocol. I will be covering this in advanced course. In Objective-C, NS Dictionary and NS Mutable Dictionary can use any kind of object as their keys and do not provide any information on the type of those objects. In Swift, the dictionary key and value types must be certain specific types only. Having studied arrays and dictionaries, we now move on to study strings in Swift. You create a string in Swift by creating a constant or a variable that is assigned to a string literal. In this example, we create a string constant called a mutable string that is assigned the string literal to the right-hand side of the equals sign. Attempt to modify this string further in your code results in a compile time error. To create a mutable string, you create a string type variable, rather than a constant as in the previous statement. Note that the type of mutable string variable and a mutable string variable in the previous statement is inferred from the assigned value to it. We now print the value of the mutable string on the console. Note the use of string interpolation that I have mentioned previously. The value of the variable to be extracted is enclosed in parentheses that are preceded by a backslash. In general, the variable can be of any other data type such as integer or float. To modify the value of the variable, we simply assign another literal to it. We verify that the string variable is actually modified by printing its value on the console. A string literal can embed any Unicode and supports the use of special characters such as double and single quotes. In this case, we use the Unicode 03C02 set the symbol for the mathematical pi. To include the double quote character, we precede it with a backslash. When you print the message string on the console, you will see this output. In this example, we first construct a message string variable. We make its contents nil by assigning an empty string literal to it. Another way of making a string empty is by using the string initializer syntax as shown here. You test if the string is empty by calling the empty method of the string class. In Swift, when you pass a string data type around in your code, it is always passed by value. It means, when you receive a string passed as a parameter within your method, you actually receive the copy of the original. This you would naturally think is resulting in very inefficient coding. However, internally the Swift compiler provides optimization by not making the copy until it is absolutely necessary. Contrast this with NSString class in Cocoa framework, where the NSString variables are passed by reference by default. You will have to explicitly request a copy if you wish to pass a string by value. In the next few slides, I will discuss a few commonly used operations on strings. This code explains how to extract individual characters from a given string. We first declare a string constant. Next, we declare a variable of character type and assign it some initial value. We will search the previously defined string for the presence of this character and count its number of occurrences. To extract the individual characters in a given string, we create a for loop. In each iteration of the loop, the character variable will present one character of the specified input string. If the string character equals the search character, we increment the count variable that was set to 0 before the loop execution begins. At the end, we print the number of occurrences of the searched character on the console. This example demonstrates string concatenation. We declare two strings, which we will concatenate in the next statement. To concatenate strings we use the typical plus operator. Note that we are concatenating three strings here. The result is assigned to another string variable called message string. The result of concatenation can be verified by printing the resultant string on the console. You may also concatenate a character variable to a given string as shown here. String class provides many more methods for string manipulations. I encourage you to go through the string documentation or simply use the context-sensitive help in Xcode editor to browse through the list of available methods. I will briefly mention a few methods here. As the name suggests, this method converts the given string to lowercase and returns a new string. Naturally, you also have another method called uppercase string to convert a given string to all uppercase. This method extracts a substring starting at the specified index. Once again, you would naturally have methods to extract substring up to a specified index and to extract in the specified range. Then there are methods to write a given string to a file or a URL. In this lesson, you learned arrays, dictionaries and strings. With some hands-on practice in Xcode you would easily master the constructs discussed in this lesson. We now move on to the next lesson on control flow. Hope you like this module. Over the past several years of iOS development, we have deployed many apps in the App Store. Like this course, many of these apps are free to download. Do visit the URL mentioned here to download and try out these apps. Thank you for supporting our development. Now, as you have completed this module, you will definitely like to look up other modules in this course. Do visit the above URL to get links to all other modules in this course.